Hello, sir. I am Aditya Gangadhar Kumbar, roll number 21, SYB Tech Civil. Today I am going to present my PPT on topic experimental studies on fiber reinforced concrete. Content: Introduction, why fibers are used, toughening mechanism, types of fibers, materials, result and discussion, conclusion. First, introduction. When fibers materials are used in manufacturing, then it is known as fiber reinforced concrete. Nowadays, application of fiber is continuously increasing in various fields. Fiber reinforced concrete is mainly used in structure due to the property that fiber enhances toughness of concrete. It is a composite obtained by adding a single type or blend of fibers to the conventional concrete mix. Fibers can be in form of steel fibers, glass fibers, natural fibers, synthetic fibers, etc. So, why fibers are used? Main role of fiber is to bridge the cracks that develop in concrete and increase the ductility of concrete elements. They also reduce the permeability of concrete and thus reduce bleeding of water. Some type of fibers produce greater abrasion and shatter resistance in concrete. Toughening mechanism. X-axis represents stress, Y-axis represents strain. As we can see, fiber reinforced concrete with high fiber withstands more stress and strain as compared to fiber reinforced concrete with low volume and as compared to plain concrete. Types of fibers. There are different types of fibers, but mainly steel fibers and glass fibers are used. First, steel fiber. The aspect ratio of steel fiber is from 30 to 250. The diameters vary from 0.25 mm to 0.75 mm. High structural strength. So, steel fiber has high structural strength. It reduces crack widths and control the cracks widths tightly, improving the durability. It also improve impact and abrasion resistance. Next one is glass fiber. Glass fiber has high tensile strength. It is from 1020 to 4080 Newton per mm square. Generally, glass fibers are of length 25 mm are used. Glass fiber improves in impact strength. It also increases flexural strength, ductility, and resistance to thermoshock. Result: in this present work, M20 grade of concrete is selected for the proportion of 1 is to 1.96 is to 2.63 and water cement ratio of 0.45, and various studies are conducted to observe the responses in addition to general ingredients. Steel and glass fibers are added of percentages 0, 0.5, 1, 2 and 3. The first test was conducted was compressive strength. The table shows the percent of addition, then steel fiber and glass fiber. So first 0% of fiber was added into the steel fiber and glass fiber, and the strength was 22.56 Newton per mm square for both the fibers. Then 0.5% fiber was added in the concrete. The steel fiber showed strength of 24.06 Newton per mm square and glass fiber showed the strength of 27.06 Newton per mm square. Third, 1% addition was done into the concrete. The steel fiber showed the strength of 26 Newton per mm square and glass fiber showed the strength of 28.46 Newton per mm square. Then 2% addition was done and steel fiber showed the strength of 27.66 Newton per mm square and glass fiber showed the strength of 26.98 Newton per mm square. Then 3% was added and steel fiber showed the strength of 28.15 Newton per mm square and glass fiber showed the strength of 26.10 Newton per mm square. The below graph shows the compressive strength per percent addition of fiber reinforced concrete. The green line represented steel fiber and red line represents glass fiber. The next test was done was flexural strength. The table shows percent of addition in both steel fiber and glass fiber. 0% addition, both the showed 3.73 Newton per mm square strength, and when 0.5% steel fiber was added, then it showed 3.9 per 3.9 Newton per mm square strength, and glass fiber showed 2.45 Newton per mm square strength. When 1% was added, it showed 4.4 Newton per mm square strength, and glass fiber showed 2.94 Newton per mm square strength. When 2% was added, it showed 4.75 Newton per mm square and glass fiber showed 2.6 Newton per mm square strength. When 3% of fiber was added, steel fiber showed strength up to 5.20 Newton per mm square and glass fiber showed the strength 2.45 Newton per mm square. In the below graph shows flexural strength in Newton per mm square to percentage addition of fiber reinforced concrete. Blue graph represent steel fiber and dark blue graph represent glass fiber. So what are the conclusions? The conclusions are drawn from the test results. In compressive strength, flexural strength and split tensile strength, the addition of steel fiber, the strength is increasing linearly, but in glass fiber up to 1%, it is increasing, and from 2% it starts to decreasing. It is concluded that the strength is increasing while the increasing percentage of steel fiber, but in the case of glass fibers, the strength is increasing up to 1%, and after 1% the strength is reducing. Finally, concluded that glass fiber can be added up to 1%. Thank you.